Hello, Royals. For lesson 2.6, where we started horizontally stretching and reflecting horizontally, I want to spend our sort of extra video time here going over the explanation again about why these transformations are reversed and why we have to have it in a factored form. So I'm not just going to repeat the examples from the lesson. I've just come up with a couple of other examples that I'd like to consider. I'm going to go through the same arguments in the lesson, though. There's not really many other ways of explaining this, and I don't want you to just, I mean, if eventually you just haven't memorized that things inside are a little bit reversed, you'll probably do fine. If you can remember that you need to have it written as a monic binomial, then that's fine as well. You have to see like positive 1x minus p, then you'll do fine. But I think that we will always do better if we understand why it is the case. That way we can build up to this understanding ourselves and we don't just have to memorize it. So f of x equals the square root of 1/2 x. Let's go back to a table of values, maybe one last time. Okay. I can still, if I need 1/2 of x to be greater than or equal to 0, x still has to be greater than or equal to 0. An input of 0 still yields an output of 0. If I want to keep my numbers to be perfect squares, inputs to be perfect squares, arguments and radicands to be perfect squared, then the next perfect square I would like, the next radicand I would like would be the square root of 1, which would be 1. If I want to make 1/2 of x equal to 1, because I am having my input before I take its square root, that means that I can now, or I must now, substitute in a number that is twice as large as it used to be. I'm not having my input. I am taking my input, which can now be twice as large before I multiply it by 1/2. Or sorry, my inputs aren't going to be half of what they used to be. My inputs can now be double what they used to be. If I want to get an argument, a radicand of 4, I used to have to substitute in 4 to get that to happen. But now I can substitute in an input of 8. Half of 8 will be 4. The square root of 4 will be 2. So this curve, instead of going through 0, 0, 1, 1, and 4, 2, goes through 0, 0, 2, 1, and 8, 2. That causes, or the effect is, a horizontal stretch by the reciprocal of 1/2, which is 2. Graphically, if my original curve looks like this, my new curve is going to be twice the horizontal distance from the y-axis. Now, if you look at that and you say that to me looks a little bit like a vertical stretch, you're not wrong. We could get it done in that way, but we're not going to yet. Let's try that same argument here on a parent quadratic. I've got a k value of 2. This one, you might think about just sort of expanding it and writing it as, isn't this just a vertical stretch by 4? You're absolutely right. It is. It has the same image as a horizontal stretch, or sorry, as a vertical stretch by 4. But if we're dealing with a set of points, which we'll see in lesson 2.6.5, then we don't want to mix those two transformations up. So table of values, again, to demonstrate or to build an understanding here. We can substitute in any number we want. If we still want, we can still substitute in 0 and get an output of 0. If I want my next input to give me the square of 1, or sorry, the 1 to be squared, which is 1, I used to have to substitute in an x value of 1. But now that my x value is going to be doubled before I square it, I only have to substitute in half of what I used to. Right? You can see that rearrangement. Here you saw it, why we ended up doubling instead of having. Here, you're going to see why we're going to end up having instead of doubling. It's the same argument about why the horizontal translation is reversed. You want to get an input, or sorry, a base of 2, so that when you square, you get your next nice square of 4. You used to have to substitute in an input of 2. Now you only have to substitute in an input of 1. The effect here is a horizontal stretch by a factor of 1/2 towards the x-axis, y-axis. Your horizontal distances are halved. Notice that doesn't affect the point on the axis. Half of 0 is still 0. It's not a taller curve. Both of these curves go up forever. It's not skinnier. They both go left and right forever. I would say it's faster. That right there on the inside is G. Okay. And then next, the argument why this has to be factored. Let's just try it quickly with an inequality here. If we want 2x minus 4 to be greater than or equal to 0, that means that 2x would be greater than or equal to 4. So x would have to be greater than or equal to 2. So this curve, its domain, is that x has to be greater than or equal to 2. And then it's a curve that goes up in this direction. So to a student that has their eyes open, it should be pretty obvious that this is not shifted right 4. It is shifted, when we remove that factor of k, right 2. Horizontal shift, right shift. At least it was not the, I sometimes forget to write the F in horizontal shift. Right 2. Okay. It's kind of an odd case because to list your transformations properly, you need to remove this k value as a factor, whether it is considered a factor or not. For example, for j, this is h here. For j, if I wanted to find the x-intercept, if I were to set j of x equal to 0, that would mean that 3x minus 4 squared was equal to 0. That means that 3x minus 4 would be equal to 0. It means that 3x would be equal to 4, and x would be equal to 4/3. So this is a quadratic, a curve that has an optimal value of 0. It hasn't been translated vertically. It's still on the x-axis. It has been shifted right. It just hasn't been shifted right 4 units. It's been shifted right 4/3 of a unit. I would upgrade these exterior brackets to square brackets. Forcibly remove a factor of 3 to see that after a horizontal stretch by 1/3, there is a horizontal shift. I have no idea where I'm going to write this. Horizontal shift right 4/3. So, like your translations, your k values, there's a little bit of a reversal, and it has to be written in a factored form. You have to have the positive 1 in front there. Okay. Let's just do one more to show you maybe like a, I don't know, little thinking situation that might come up. Sometimes students call these trick questions, but there's no trick to it if you know what you're doing. If I ask you to sketch the square root of, I don't know, how about 4 minus x? There's a number of ways that you could sort of reason through this. First off, I hope that it's relatively visible that 4 is going to be your one and only one x-intercept. I'm not so sure if it's obvious in what direction the curve goes from there. You could probably figure it out though. If you start substituting in numbers larger than 4, like 5, f of 5 is going to be the square root of -1. The square root of -1 doesn't exist. You substitute in f of 3, you'll get 4 minus 3, which is 1. The square root of 1 is 1. So even just, I mean, that's like a kind of using the table of values to do it, but how about I asked it to list the transformations instead? Well, this doesn't really look like a times the square root of k bracket x minus p plus q to me. I'm pretty sure my a value is 1, my q value is 0, but notice the reversal here. And that's what students call like the trick. Well, that's not much of a trick. If the most difficult thing that a teacher is going to throw at you is that they're going to reverse the order of terms, there's a lot worse that they could do to check your understanding. Now I have it written in this format. There is a horizontal reflection. This is not shifted left 4 though. I don't really like asking this question because sometimes students make 2 mistakes and they eliminate each other. They think, oh, plus 4, that's going right 4 because plus means right. Well, they're wrong, and they also forgot to remove the factor, so they made another mistake that sort of eliminated itself. There's got to be some sort of wording here where I would force you to show your work or something like that. I remove the factor of -1, that leaves me with x minus 4. So from my parent, y equals the square root of x, I have a horizontal reflection or a reflection across the y-axis, followed by a horizontal shift right 4. To sketch that, parent function, horizontal reflection, shift right 4, tidy that up, maybe label this 4, 0, vertical out of the endpoint vertex, if you like, label the curve. We weren't asked for the y-intercept, but it's not hard to see that it's going to be 2. That's a quick check. Okay. Those are the most common errors. Students not rearranging, not removing factors, and not reversing transformations.